Okay, so for the last video for skill number 4, I think it'll be the last video. I guess I shouldn't count my chickens before they've hatched. We're going to do something where we mix it up a little bit. So in this case, in this example number 3, they're asking what is the angular speed in RPMs, right? Rotations per minute. If you have 3-foot tires, so these are like tires on a very big truck, that is traveling at 55 miles per hour. So say you're driving a truck, you're driving it at 55, you kind of know that the tire size is 3 feet. And you're thinking to yourself, okay, well, I wonder what the RPMs are at the wheel. Maybe you're just bored because you're driving hours and hours and hours every day, and you're trying to sort of do a quick calculation and say, okay, I can sort of see the engine RPMs in front of me on the dashboard. I wonder sort of what the conversion rate is. And again, this will probably depend on the gear that you're in, but I sort of wonder what the sort of connection is between the sort of engine RPMs and the RPMs at the wheel. So let's see if we can't work this out. Essentially what we're doing is we're trying to sort of unpack and reverse the formula, right? We're trying to sort of reverse the formula that we have before, because rather than being sort of given the angular speed and the size of the tires from which we can get the circumference and find the velocity, we're now flipping it around. We know how fast the car is moving, the truck is moving, so we're trying to go back and figure what the angular speed is. First things first, circumference stuff, regular stuff, pi times diameter, pi times 3 feet, 3.425 feet, good to go. That's just our circumference. So, okay, the next thing, right? So my velocity is my circumference times the angular speed. So this is what I'm solving for. I've got the velocity. Part of the issue here, right, is my velocity is kind of miles per hour, but my circumference units are feet, in some sense, I guess, feet per revolution. So my units are not in sync at all. What I really need to do here, right, the kind of fast version of this formula, I guess you can see it down here at the bottom, right? The sort of fast version of this formula would just be, right, if your velocity is going to be the circumference times the omega, well, the omega would just be the velocity divided by the circumference, right? Whatever your linear speed is. If you just divide by however big your tire is around, that'll get you the rotations. But the units are all out of whack, right? I'd like to get my rotations per minute, but my velocity is per hour, and then I have distance units that are all out of sync, miles and feet. So what I need to do is maybe convert my velocity into feet per minute. And that way I can do a division and end up with the units that I want. So this is all about syncing up your units before you divide. So if we do a quick conversion here, right? So 55 miles per hour, 55 miles for every 1 hour. So I want to convert it from miles per hour to feet, right, per minute. So 1 hour would be 60 minutes, right? So 1 hour over 60 minutes times 5280 feet per mile, right? So I'm trying to cancel miles with miles. I'm trying to cancel out hours per hours and get feet per minute. So 55 times 5280 and then divide by 60. That's going to get me this 4,840 feet per minute. So that's just a unit conversion, right? This is still effectively the same value. It's just converted into different units. The reason then, right, is so this should be my circumference, which was where? 9.425 feet, technically, per revolution, times my omega, right? So these two things are going together. So now if I do a division by the 9.425, I'm dividing, and I'm doing that here, right? Feet with feet. Technically what happens, there's a little sort of switcheroo here. You sort of have, you're dividing by something that's divided by revolutions. That's sort of going to flip the revolutions up to the top. We're playing a little fast and loose here. You can kind of just take my word for it, or you can kind of write it out in a little bit more detail. But as long as your time units are what you want them to be and your distance units match feet to feet, you can do a division and then get to your answer. So your angular speed, right, feet cancel feet, you're going to end up 4840 over 9.425, looks like 513.5 RPM, right? So the angular speed at the tire, 513.5 RPMs. Let's run one more, something similar, just sort of, again, from the exercises. I'd like to look at number 14. So this is a car with 19-inch tires. So rather than those monster truck tires that we had a second ago, they probably aren't monster truck sizes. But rather than the large truck tire that we had a minute ago, more regular sized car tires. And you're traveling 67 miles per hour. So find the angular speed in revolutions per second. So here we go. I've sort of rewritten our important information. Is that going to go away? Thanks very much. Get on out of there. So my diameter is 19 inches. My velocity, right, my linear speed is 67 miles per hour. I want the angular speed, but I want it in revolutions per second. I want sort of RPS. So as always, I need my circumference first, pi times diameter. This is actually the same number we had in one of our previous examples. I don't remember what it was. It was like 59 something, 3.14 times 19, 59.66. Not the worst memory in the world. So 59.66, that's my circumference in inches. Okay. So the setup here, right? 67 miles per hour. So that's my velocity. Should equal 59.66 inches times this omega, right? That's my circumference times the omega. So my issue here is my units are all out of sync. None of them really match at all. And of course I should mark here that I want revolutions per second. So I need to do two conversions to my velocity. I'm going to need to convert this into, I need to match my distance units. So I want inches, and then I need to match the time units. Inches per second. So I don't want miles per hour, I want inches per second. Let's make it happen. Let's not think about how that's kind of annoying and how the numbers are going to be sort of big and small. It is what it is. We'll live with it. 67 miles for 1 hour. So what did we say? Inches. So I got to do 1 mile is 5,280 feet. And then I know there are 12 inches for every 1 foot. Okay. So that would be, right, miles for miles, feet per feet. 67 times 52 times 12, 1 and 1 and 1 on the bottom. That would be inches per hour. So that's going to be a really big number, but that makes sense because if you're going 67 miles an hour, you're going to go many, 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 many more inches. So then my time, I want to convert from hours to seconds. And these, of course, are units that are, time units that are on the bottom. So I'm trying, so canceling hour on top. 60 minutes for every hour. And then I'm going not just per minute, but down to the second. So 60 seconds per minute. So what happens here is there's a little bit of a balancing, right? So I've got sort of some multiplication up top, but it's getting balanced out with some division on the bottom. And so this is, what did we say? So hours per hour, and then minutes per minute. So I'm just converting this velocity into inches per second, right? Here are my leftover units. Here are my leftover units. So what is this number actually going to be? Let's find out. Let's do this up a little bit so you can see me calculate. So 67, we'll just go in order, right? So stuff up top, 5 times 5280, pretty big, times 12. So again, halfway through, so that's 4 million and change, right? But that's inches per hour. So again, we expect that to be a lot of inches. If we divide it by 60 minutes, right? So 70,000 inches per minute. If I divide that again, I'm going sort of 1,179.2 inches per second. That's a lot of inches per second, honestly. In fairness, 67 miles per hour is pretty fast. You know, it's not like race car fast. That technical term, race car, that's a thing. So 1,179.2 inches per second. Okay. So then that should be equal to, what did we have before? I'll sort of pull this back down, right? So 59.66 inches times whatever this omega is, right? So I've sort of set up here, right? That's my equation. So 1179.2 inches per second equals 59.66 inches, right? Times my rotations per second, right? This is the distance in one rotation, so times however many rotations we're doing in a second would get us here. To undo this, right, and to solve for the omega, I'm just going to divide by my 59.66 inches. So divide that over here. You'll notice a little bit I'm kind of skipping, putting in this is sort of inches per revolution, and that I'm just trying to sort of simplify the work just a little bit. Obviously the units here are super important. You need to keep track of them to know what the heck you're doing. But you can do a little bit of shorthand just to save yourself some time. So divide by 59.66, looks like 19.765, we'll call that 19.8. And that's revolutions per second. So, you know, effectively 20 rotations at the wheel per second to go 67 miles per hour. You know, if you think of like how fast the car is moving, I mean, you know, you'd have to have it sort of up on a rack or something to really like look closely at the wheel and have it going 67 miles per hour. That sounds pretty intimidating, honestly. I wouldn't really want to be standing right next to it. You know, if you imagine cars driving quickly by on the highway and trying to look at, you know, how fast their sort of wheels are spinning, I guess it's about, typical car, you know, about 20 rotations per second, right? So it's pretty fast. That's humming along. But that's the idea, right? So that's a couple different versions of this. A really great sort of conceptual kind of challenge problem here, or an idea to think about is if you have your car set up with a certain size tires, right? So say you have whatever, you know, 18-inch again or 19-inch, right? And again, this is not the rim, but the actual physical tire. And if you have tires that are a certain size in your car, and then you put bigger tires on by, let's say, 1 inch, assuming you have space in the wheel well to do that, what will happen then if you don't do any changes to your car? You know, your engine, the car itself, is sort of set up with a certain size tire. If you put a bigger tire on there, you're going to go faster than you think you're going. Your your speedometer is going to tell you you're going 60 miles an hour, but because of the extra size on the tires, you're covering more distance for every rotation, which means you're actually going faster. So if you know how much bigger your tire is, you can sort of do a quick calculation. You know, if you actually did this and put, again, not just different size rims on, but physically different size tires, you can sort of do a calculation and you can adjust your speedometer so that it's still in sync. So something to think about.